Jason, do you see my screen?
Sure do.
Great. All right, while we're waiting for a few more people to join in here, I'm just going to go ahead and get us started with some housekeeping items. So welcome to our presentation today. My name is Katie Schauer, and I'm the Digital Marketing Specialist here at InSource. I appreciate you joining us this afternoon during your lunch break to have a deeper dive into one of our great topics here. Just some housekeeping items before we begin. We are recording today's session and we will be sending that to you later next week, along with anyone who's missed the session. We will also be making it available via our website so that you can revisit it. If you have any questions at any time during the presentation, please utilize the Q&A or chat box and we'll be happy to answer those at the end of the session. We will also have a quick poll at the end of our session just to find out what you'd like to hear more about. So if you would please respond to that as we open that up at the end of the session before we get into Q&A. With that, I'd like to introduce Jason Paquette, who's going to get us started.
Thanks, Katie. Thanks, everybody, for joining us today. My name is, as I said, Jason Paquette. I'm the marketing manager here at InSource. Before we get into Xperts on top, I'd like to give you a little, start out with a little, a bit about telling you the purpose and our vision and unifying principles at InSource. So InSource is a company with a strong culture, a clear sense of purpose, as well as a unique approach to fulfilling that purpose. This is relevant in that it allows us to establish fit more quickly, knowing our strengths, and that we work best with clients that have similar value and culture. From edge to enterprise, we operationalize digital solutions to deliver transformational results. Our ultimate vision really is to revitalize manufacturing in America, and today we are heavily invested in making the industrial digital revolution a reality for thousands of industrial companies. We bring Industry 4.0 technologies and beyond to the table, and then we add our secret sauce, we like to say, and that helps companies truly integrate those technologies into their processes and routines. In other words, what's unique about us is that we operationalize manufacturing IT solutions. Next slide, Katie. So this is a new series that we created. This is our first one. It really is, the purpose of this is to take a deeper dive on topics that we sometimes just kind of skim or overlook. So we got this list together for people specifically like you in mind to hit these different topics. And like Katie said at the end, we'd like you to take part at the end because you can control our destiny and on the different types of topics that we go. We really want to narrow this down to 30 minutes of your time only, and we can pretty easily get that done. So today, our topic again is AVEVA application server scripting. And our experts today are Ted Fluehr, who's our system consultant, and Ron Tanner, our technical solutions architect over at InSource. So I'm going to pass this over to Ted.
Everybody sees my screen there?
I see it. You're good.
Sounds good. Well, welcome all. Appreciate you all joining us today on your lunchtime. Hope everybody's doing well in their lockdown situation. I'm starting to get a little antsy. Want to get out and see some customers real soon, but we're taking advantage of this opportunity to do some learning for our customers while we're in this lockdown situation. We're going to talk about application server scripting, and I'm going to kind of show you some basics, and then Ron Tanner, who's one of our developer programmers, going to go a little deeper into some things. You know, the application server scripting, there is a manual for this called the Application Server Scripting Guide. It's on the roof of the install CD for any of the Wonderware products or AVEVA products. So if you drill into that and you drill into application server, you'll see documents and you'll see this application server scripting documentation. But it discusses all the different types of functions and things. So it does talk about the functions that are available to us. We call our scripting language QuickScript.net, right? So In a nutshell, it basically has a lot of different functions that we can call. You know, some of the things are graphical functions. You know, if I wanted to, you know, show a graphic or hide a graphic or log off or show some content, there's some script functions in there to do this. So this document kind of shows you the syntax that you're going to use there to get in and see that graphic function, right? So here's how you would say hide self, hide the particular graphic, or this is how you would open up a graphic. This is the script right here that's going to show you how to hide a specific piece of content in your system. You know, there's math functions in here, standard mathematical functions that can be used, miscellaneous type functions, log some messages. This is a very helpful utility here to log a message to the logger. If you try to do some troubleshooting of a script, you can use the log message function to be able to write that out to the logger to see what's going on. Those types of things. String functions, concatenate strings, break strings apart, all those types of functions are available within the scripting language. You know, Ron's going to talk a little bit how we interface with .NET and things like that and how we can link to DLLs in the future. But that's kind of the overview of the script. There's all kinds of example scripts here. You know, if I want to interface with Excel or I want to link to an XML document, right? There is some SQL statements. Ron's going to drill into SQL statements here also. I want to write information to a text file. So there's some great examples in this documentation to be able to see how to build those different scripts. So we'll leave that document aside and we're going to move on into a live environment and show you some real world examples of some scripts. So I'm inside the IDE, Integrated Development Environment, is where we do our programming for the script language within Application Server. And, you know, I have something called a service pump station demo object running here. And this service pump station demo is a complex object and has other objects listed underneath it that you can see over here on the left-hand side. But this object basically is going to house some of my graphics. And basically, there's an OMI application sitting here running that's showing me some status information about an application. So there's the graphics on the other end of it. But let's say a very simple script if I want to create a variable and I want to basically add two numbers together, right? The very basic hello world script, if you will. So the first thing I would need to do is define an attribute. And let's say I want to define this attribute here as flow total. So I'm going to create an attribute called flow total, and this is going to be a floating point number. And we're going to see in a little bit where we can actually create some variables inside the scripting environment. But in this case, we're going to create attributes inside of Application Server, and then we're going to have a script that's going to fill in that attribute. So if I go to my script tab here, I'm going to create a new script, and it's going to call flow tot. So I'm going to use that script to create a new flow total. You know, if you look at the scripting environment, this is the graphical user interface you have to build that. And one of the first things you have to define is the execution type. Do I want this to execute all the time, or when this script first starts up, or when this object first starts up, you can execute the script. You can determine when this script gets executed. The other thing is the expression. You know, if you wanted to link to some variable to say, I want to kick off this script while this variable is true, you could do that. So I could go here and I could browse to my different attributes, right? And I could go find something and say, okay, I want to go look for a variable that I'm going to use to see if I'm going to use this flow total number. So if I go here and say, I want to go look at this fixed pump, if this fixed pump is running, right, double click, then when this pump is running and while it's true, I'm going to execute this script, you know, every 5 seconds, if you will. So that's one option, right? You're going to define the expression and you're going to define what happens when this script is running or how often it's going to run. You also have other trigger types of, you know, while false or on true, right? So if you think of on true, if you're a PLC program, that's a kind of one-shot rising. So when something goes to a true state, it's going to fire off that script one time, and then it's just going to go dormant until it goes false again, then true. Data change, I want to look for a data change of a variable, and that's going to trigger the script, or periodic, right? I don't care about an expression. I want to run this script every 5 seconds, no matter what. It's going to do that. So let's go actually build the script. So the scripting language has something called IntelliSense. So I'm at this service pump demo number 1 here, and I'm going to look for this variable I just created, flow totes. It's not going to be IntelliSense because I haven't put it in there yet. So flow totes is going to be there, and that's going to be equal to, we're going to add a couple other variables here. So I'm going to do a browse into station flow 001 dot flow total, right? So there's IntelliSense working for me. Plus, I'm going to add another attribute here, and I'm going to go station flow number 2 dot flow totes, right? So that is going to basically just do a very simple script. It's going to add 2 flow variables to a flow total in my service pump demo station, right? So very basic script, 101, linking to attributes that I have out there in my system. I can browse to them. I can use IntelliSense to make that happen and create that script. All I'd have to do is kind of check that script in, deploy it, and then I could see that data. So I'm going to check that script in, basically close this attribute, check it in. I'm going to have to redeploy this object here, and not going to do a cascade on that. So then if I go into object viewer on this station flow, go to object viewer, and I'm going to go find that flow tote variable that I just created, and it should have some information in there, right? So if I go find that, there's my flow totes, add that to my watch list. So there's that flow tote. I just created that script. Now there's some live data coming in there. So basic script 101. If I want to do something else with some scripts, if I want to do a little more deeper dive in the scripts, if I want to take a look at some of the scripts I have already defined, if I look at up here at my pump stations, I have a script here that's going to calculate my power consumption. I'm going to look at my derivation view to get the master template of this guy. I have multiple instances of this. And if I look at this variable pump right here, this variable pump right here is going to calculate the power consumption. So a couple new things we're introducing here is the ability to mention attributes inside the script language, right? So I'm defining these variables here as opposed to defining them as attributes in my objects, right? I'm defining them here. Now the difference is these are can only be used inside the script environment. I can't say display those on graphics or things like that. But here's the whole concept of the scripts that we define here. It's using something called relative referencing. Before I hard-coded some attribute names, but I'm using something called relative referencing here where I'm using me dot, right? I'm using me as a replacement for the actual object name. So you can see this pump variable over my derivation view, there's many instances of it. And the beauty of application server is I can make the script very generic and one time create the script generically and use this keyword me, and me would get replaced with the actual variable pump that I'm going to be using, right? So if I have 50 of these, me is going to be replaced with the actual pump instance. So when I instantiate an instance, me gets replaced. So this makes the scripting language very generic, so I can develop scripts one time at my master template level and then roll those things out. So you can see I'm just using a script here. It's checking to see how many phases I have here, and it's adding up the 3 current phases, the 3 current signals that I have here into something called total current, right? And it's adding that information up, and then it's going to, figure out the average current based on the number of phases and do a little bit of math, right? The basic divide function here in this script function. And then, we're also going to calculate how fast the pump has been running or how long the pump has been running. And then here's the actual body of the script, right? We're ultimately calculating this power consumption, and this is an attribute that's previously been defined. right? So if I go here, you'll see these scripts or these attributes defined here. There's the power consumption attribute that's previously been defined. So the script is going to fill that in. And it's going to go take, you know, the nominal voltage times the current, the square root of 3 times the power factor, you know, times the runtime divided by 1,000 and come up with that power consumption. So if there's any power engineers on the call, they could probably validate that or tell me that's true, a valid calculation there. But this is an example of a script that's going to calculate the power consumption of an object and put that information into a graphic. And if I go back over here to my pump, you know, that's the variable right there. That kilowatt consumption right there is the thing that's being used to calculate that power consumption that you see there. So another use of a script within application server. The key here is also the expression. It's when this pump is running, and I'm not sure why it's using the off state, but this script is using the on state and the not off state is when it's going to fire off this script here. So I'm going to move on to another little script function from here. So the other thing we have as far as relative referencing, if I look at this flow scaling script, and I'm going to put a script here, this script is going to calculate the flow total, but it's doing something called looking at my container. So when I drop this script in underneath another object, it's going to reach up into that container and find that flow total, in this case, just divide by, multiply by 0.1. So this way you can make a script very generic, drop it underneath the script, and then it's going to reach up into its parent to get the information. And there's other functions here like my area or my container or my engine or my platform. If I wanted to reach up into these other objects and get some information, and you could go grab that information from another object. So if I take this this object, I'm going to check it in. So if I make an instance of this flow scaling, make a new instance, and I'm going to drop it underneath something. I'm going to take it and I'm going to drop it right underneath the station flow, right? And I deploy that. What it's going to do, the script is reaching up into this object called station flow that has a variable in it, and it's going to execute that calculation, right? So that's something called relative referencing, and it's the ability to reach up inside of other objects to get that information. All right, well, I'm going to move on in the interest of time here. The other thing we can do with scripts is we can embed some scripts inside of graphics, right? So if I go look at this graphic I'm looking at here, this pump station, it's not exactly situational aware, but these blades are turning. So what makes those blades turn, there's a little script behind the scenes that makes that happen. So if I go dissect that a little bit, and I kind of right click, there's some custom properties inside the graphical element. You know, the blades are on, the blades are off, the blade position and things like that. So if I go look at the script here, you know, while this script is running or while this graphic is showing, it's going to execute this script every 500 milliseconds. So basically it's incrementing the blade position. So it's basically incrementing this variable, and then there's some visibility attributes that are turned on within the blades themselves. So if I go look at the attributes of this blade 1, it's basically looking at the visibility. When the visibility is on, it's going to turn on those sets of blades. When those counters of the blades are incrementing, it's basically turning off those different blades. So when you look here, it looks like it's spinning, but really is happening, it's turning on those different sets of blades based on this counter that's being executed here inside the script. Right? Just another example of a script that we can embed inside a graphic. The other little example I have for you from a graphic is the good old happy face that comes in the orchestra library. If I click on this button, this guy's going to wink at me, right? So what's going on behind the scenes there? There's a script going on that's helping with that blinking of that attribute here. So if I look at the happy face and I look at the script, right, there's some scripts going on here on show and while showing. So if I click this left wink blink, is an attribute here, it's decrementing the eye size by 1. So it's executing the script, it's changing the size of that eye and making it look like it's really blinking there. So just some examples of some scripts that we have that can, you know, be embedded inside a graphic. So any graphical element can act as its own standard little widget to show information. So, you know, that's the very basics of scripts, you know, kind of 101 hello world of script. I'm going to pass it to Ron, who's going to do a little deeper dive into some of the .NET and some of the SQL calls that you can do within the scripting language.
All right, thank you, Ted. Can everybody hear me okay?
Yep, I can hear you great, Ron. Thanks.
All right, perfect. So everybody should be able to see my screen. Let me move some things around here. So Ted gave you kind of the brief introduction to scripting. I'm going to dive a little bit deeper. Some of the nice things that you can do within the application server environment is you can actually tap into the .NET, Microsoft .NET library that's physically on the machine, or if you wanted to, you could create your own. So I actually created a what we call a simple DLL. And for those of you on the call that may not know what a DLL is, I'm going to kind of give you a graphic here to just demonstrate what they mean, and hopefully we can answer any questions in the question and answer session. So a DLL is nothing more than a dynamic link library. So the way the Orchestra framework works is we have engines that run their executables, and those executables, you can write a dynamic link library that gets loaded on top of that executable. And the dynamic link library allows you to have some properties and some methods. You can think of methods as functions for those of you that may be a C++ environment. So this little script, this little DLL that I wrote has a base class, a simple little class called simple string, and it exposes a couple of properties called public string, example string. We're going to get, and we can set those, and then I've got a method in here called get string name, and when you pass it in, it's going to replace the word down there that says example string, and then it's going to concatenate that with another string called is the current value. So once you build your dynamic link library, then you would go up to Galaxy and you would import that into the script function library. And once you do that, to make sure that it's actually in there, you can go and you can export the script library. And if you look in there, that simple DLL's already been imported. So then you have the ability within an object to actually use that DLL. So here I'm dimensioning the DLL, if you will, the object, instantiating the object. I'm instantiating also a string value to hold that. And then I have Ted talks about the me. I have an attribute called trigger DLL or trg.dll, excuse me. All I'm doing here is resetting it back when I actually call it on true. So it'll go from on true to on false automatically. Don't have to do anything there. Here's why I instantiate a new object from that DLL. Okay, simple string. And down here is where I'm actually using that and passing in Ted and passing in Ron. So once you do that, and we've got it, I've already got them deployed in interest of time, we can come over here to our object viewer. And I'm just going to trigger this call to the DLL. And then I'll show you, I'm going to just push it to a log message. So when I double click here and I say trigger it, click OK. Get back over here, it says example custom DLL.scDLL, which is the name of my script. And it says Ted is the current value and Ron is the current value. Now let's review what I did there. Here, all I'm doing is logging the message of my S value. And in my S value, I'm actually calling the get string name, and I'm passing that Ron and Ted into it. And then because the DLL is actually concatenating the two together, then it comes out like this. Now you may be asking yourself, okay, well, that's all well and good, but what is the real purpose? What can we use this for? Let's say that you had a proprietary algorithm that you wanted to, you were an OEM and you wanted to push that out using application server. Well, that's a classic example of where you can actually I can't say the word, but you pretty much encrypt your code in the DLL and then no one can decompile it. But then you put it in the system platform, and when you deploy it, it pushes that out for you, and you can use that in your scripts. One other thing I'd like to mention is you'll notice that when we put here these DIMs, which is declarations, we're declaring it within the script itself. That means that these are only scoped within the script. If you were to go up here to this declaration section and you put them in here, then if you had 15 scripts, you can reference those in those 15 different scripts, whereas the way that we do a local, it gets destroyed at the end. So that's the simple DLL. So let's talk about how else can you leverage it? You may say, I'm not a .NET programmer, or I wouldn't even know how to open Visual Studio. Well, the nice thing about it is you don't have to. There's already a bunch of different .NET capability already in the system from Microsoft. So if I were to click this function, there's a lot of different types that you can go in here. And if I go down here, I'll find my simple DLL that I imported, but there's many, many others. So let's say that you wanted to actually write data to a database. It's a pretty common functionality, or read data from a database. So I have this example object in here. I created some attributes. The first one's a connection string. I create another attribute called reason groups count. It's actually when we go and query the database, which I'll show you here in a minute, it'll actually pull it back and put the reason count groups into it. And this is, again, my trigger SQL client. That just allows me to trigger the script to actually execute. So let's take a look at this script. Same concept that you've seen before. We're dimensioning these guys, these objects, and these names can be anything that you want them to be. Typically, from a programming perspective, if you see the word O in front, it normally means an object. If you see S, it means a string. DT is a typical data table. You may have I for integer, and the list goes on and on. The other piece that I want to point out here is there's try and catch. The nice thing about a try and catch is that the program or the application is going to run. It's going to run this code. When it runs the code, it's going to try everything that's in the try block, and then any errors that occur, it's going to, if it crashes in here, then it's going to catch them, and you can push them out to the logger automatically. So if you ever see that try and catch, and then end try is just telling it that's the end of it. It's almost like a if else, and the else kicks out and then it no longer runs. So we highly recommend that you actually use the try catch. The other piece that I want to point out in this script, and this is extremely, extremely important, when you go out and you're executing against a database or anything for that matter, you want to make sure that you run that script asynchronously. So you could write a script that could hang up your application server. You wouldn't want to do that. So anytime you're going out to the database, you either write the script to where it's actually checking, the database could be down or something else. You want to run those asynchronously just to make it speed up and run in its own process. So let's take a look at the script. Here I'm creating the actual string builder. So I'm going to build my string that I'm going to go and pass to the .NET framework to tell it to go get the data from the database. In the database, I'm just selecting the reason group from the process data. So let's go take a look at that database real quick. So here's the table, the columns within the actual database table. And you'll see there's 4 rows in there. So let's go back to our script, and when I read it, I'm going to build the command. I'm going to open the connection to the database. I'm going to execute a reader, SQL reader. I'm going to check to see if it has rows. If it does have rows in the database, then I'm going to load them into a data table, and I'm going to populate my local attribute called reason group count. I'm going to pass in the actual rows that it returns, because I'm actually finding the the number of reason groups in that table. You'll notice there were 4 rows, and then I'm going to log that message. So let's go ahead over here to the object viewer, and let's execute our script. And I've put the attribute for the reason group count so you can actually see it. So it's going to go out, and then when I click true, it's going to go run the script. It's going to come back, and it's going to give me a result set of 4. You also notice that I logged the message. So here's where it actually says example DB integration, the SC query SQL client, and the row count returned from the database is 4. So hopefully you gleaned some information about what you can do from the .NET framework. Again, a lot of these things that Ted talks about, you can do the same type of scripting and querying from within the actual Orchestra graphic. So you could drop in a .NET grid from Microsoft onto an Orchestra graphic and then populate that Orchestra or that Microsoft grid within the Orchestra graphic with actual data from the database. Okay. All right. I appreciate it. I'm going to stop sharing here and pass the ball back to Katie, I believe.
Yep, it would be me. I'm taking it now. Hold on
Alrighty.
a moment. All right, let me get myself set up here, guys. So I'm going to open our short poll here. One moment. I need to share my screen. Okay, perfect. And I'm going to open our poll. So our poll is going to be open for about 2 minutes. So we're just asking which topics are of most interest to you. And we gave you some choices. And then if none of those choices are working, or if there's something you wanted to add, feel free to enter that into the second question. And while we're waiting for people to answer that, I also want to remind you that we do have the Q&A and chat boxes open for questioning. We do have a few questions that have come in so far, so keep those coming as well. Let's go ahead and get started here with our questions. All right, so our first question, how do you remove a DLL after it has been imported so it no longer is in script function browser?
Okay, that's a good question. So first thing, obviously, if you were to use a custom DLL and you had scripting associated with an object, you would first obviously remove all those references to that particular DLL. Then there is a tech note on how to actually remove it. It's stored within the Orchestra database that's creating behind the scenes. So you would go in and run a T-SQL script, and it would go and remove that DLL as a reference within the Orchestra database system, and that's how you would do it. So typically, that's the approach we take. 90% of the time, once you create a DLL and import it into the Orchestra system, you wouldn't be removing it. You would just be upgrading it. So hopefully that answers the question.
Okay. And I'll remind you guys, if you have any questions, feel free to put them into the Q&A and chat box. Our poll is almost over. All right. Great. Okay, let's see. Oh, I've got another one here. Oh, this is just a comment, but I think this is great for this group of people. Another topic I'd like to see is alarm system and database. So Jason, if you want to make sure to make note of that, we can make sure that we add that to our list of possible topics for the future. Just check here. Ron, do you happen to have the tech note number for removing the DLL? If not, if you can email it to me and I can send it over to the person who asked, that would work too.
Yeah, I'll see if I can find it.
Yeah, if you can find that, that'd be great. And Mohammed, I'll send that over to you. Just making a note so I don't.
One follow-on to that question is we need to know what version of application server you're currently running that you're trying to remove it from.
Okay. All right, here's some more questions. with redundant app servers, why would a script only run when on the primary? Ted, Ron?
Sorry, I was looking for the tech note.
No worries. I didn't know if Ted, is Ted still on?
Yeah, I think Ted's still on. So with the redundant app servers,
Yeah.
you talking about a failover, or are we talking about true redundancy? Or what do we talk? I need more detail because it says why would a script only run when on the primary?
So the whole idea with when you have application server redundancy, the object only runs one place. It doesn't run continuously on the primary and the backup. It's only running on the primary or the backup. So there's no way to actually run the script on the primary and the backup at the same time because they're both not polling. So basically one is kind of, when you're in backup mode, it's sitting there dormant, waiting to take over if the primary should die, and then it would execute the script. So I think the question is, why would the script only run on the primary? Right, because there's only one object running at a time, either primary or secondary. They don't both run at the same time is the short answer.
Okay. Great. Our next question, what changes have been made to scripting in 2017 and 2020 versus early versions of system platform?
So I can answer that. I know for 2020, there's something called OMI that we have out there, right? The new graphical user interface. And there's a lot more scripting function available inside of the OMI environment within 2020. So that's one of the big gets with the 2020 release as far as scripting. Ron, anything else you know of there?
I'm thinking. Well, there's some changes when the scripting in the orchestra graphics, but I can't. So I think we need to know more of what you're looking for. Are you looking for new functionality, or are you looking for compatibility? What? I mean, there's got to be more to the. In my mind, there's more to the question than. Is it like a what's new that you're looking for, or? Hopefully that makes sense what I'm asking. I feel like I'm meandering a bit.
Yeah. Jason, if you can clarify in the Q&A or chat box, that would be great. There's another question here while we're waiting for a clarification. Oh, Jason, I'm sorry, here we go. Jason's saying new functionality.
Yeah, I'd have to go look at the what's new. Sorry, I don't have that.
We can get you the what's new.
Right.
We can get you the what's new for those versions.
Jason, I'll get your info. I have your information, and we'll get that information to you. Okay, our next question. This is a redundancy question detail. Several calculated values only work when on the primary app server. When failed over to the backup, the value is 0. What are some possible causes? This is a clarification to the earlier question.
Where's that? Say that question one more time. Sorry.
Right. So the earlier question was about with redundant app servers, why would a script only run when on the primary? And this is the clarification. Redundancy question detail. Several calculated values only work when on the primary app server. When failed over to the backup, the value is 0. What are some possible causes?
It's because typically what will happen there is that it's a scope, right? So it's in memory on one. So if it's a calculated value, it's probably calculated within a memory space. And then it's not initialized with that when it fails over. So you need to make those calculations static, where, if you will, global. So when it fails over, it doesn't know. In other words, you need to know more. It's kind of a deep question, but I need to know more about the script and how the script is actually written. If they're using local dimensioned variables are in scope when it comes into memory. If it's tied to an attribute, that's something different. That actually writes, it's written to a static location versus an in-memory location. So if to answer your question without getting down, without asking more questions, then I would assume that the problem is one's a memory variable And one's, that's the reason when you go to the failover, it doesn't know, it just initializes it as 0 because it doesn't know how to do the calculation. Then when it runs through its cycle again, it should calculate it again. Hopefully that makes sense.
Okay. I have another question here. When you make a DLL declaration in declaration box in IDE, does that mean it stays in stack for the life of the object? And is it only one instance for the child objects?
So it's kind of hard to let's see, is it in scope for the child object? It really depends upon what type of object we're talking about. If you created a custom DLL and declared it at the top level, then any script that you run within the object has that availability. If you're talking about scripts outside the object, then no, the children are separate. You'd have to do another declaration. I can't see that you'd really want to do that from a memory namespace, from a memory allocation space. If you need global values, then I would put them in the attributes and use them there. So write to the attribute from the master DLL and then use those attributes. Because you got execution script times. Each one of those scripts can run at a different time frequency. So you have to remember how application server works. It is a state engine. It's sitting there spinning like a clock, right? So the seconds on a clock, and it goes around and around and around. And you can have different script cycles running. So you could get yourself into a situation where you could instantiate and run something with a custom DLL and it spits back information, but you're not going to catch that information until the next cycle of whatever the script run and also the engine cycle. So if you have a scan rate of, 1 second or 5 seconds on the engine or 500 milliseconds on the engine, there's a lot of different variables. Hopefully that answered that question. I don't know if I did or not. These are good questions, by the way.
Great. All right, that looks to be, oh, yep. Mohammed said you did, you answered it, and thank you.
Okay, all right, good.
Great. Perfect. So that looks to be all our questions for the moment. If you do have more questions, please feel free to communicate with us via our email address, which is communications@insourcess.com, or you can visit our website at insource.solutions and fill out our contact us form there, and we'll be happy to get you in touch with the right people. Like I said, this has been recorded and we will be sharing that next week. And I'd like to take this time to thank Jason, Ted, and Ron for their great presentations today. And we look forward to seeing you guys on future episodes. Thanks and have a great day.
See y'all.